the first step every single time is what? Every single time we have one of these questions, if I ask you to compare fractions or to add fractions or to subtract fractions, first step is always find a common denominator. I need the bottoms the same. So I have 3 over 12 and 4 over 16. There's 2 ways I can do this. The first is to do it what we call the old way, right? Which is to just start writing down multiples. 36, 48, 60, 72, 84. And these would have to keep going, keep going. Does anyone know how far we'd have to go to find the common denominator? 16, 32, 48. And as soon as I get there, I'd realize this matches and this matches. That's where I would stop. That's not super impossible. Like some people could look at 12 right away and 16 right away and know it's going to be 48. But some people are going to struggle with that. If you need your calculator and you need to keep going, 12 times 1, 12 times 2, 12 times 3, that's okay. Whatever you got to do to get that laid out. So once I know it's 48, here's what's going to happen. I'm going to start with something over 12, and it's going to become something over 48. And I'm going to start with something over 16, and it's going to become something over 48. Now once I'm in this spot, what question do I need to ask myself? Chantal? Absolutely. What did I do to the 12, or what did I do to the 16 to make it a 48? Because we need these fractions to stay equivalent. So what did I do to the 12? Layla? I multiplied it by 4. And the easy way to check that is I just count how many multiples I had to do before I got there. So 1, 2, 3, 4. It's the fourth one, so I multiplied by 4. And hopefully this is starting to be something that you don't even have to think about anymore. So 12 times 4 is 48. What's 3 times 4? 12. And now what did I do to the 16? Same exact process, Mr. Sweeney. Multiply by 3. 1, 2, 3. So if I'm multiplying by 3 there, I need to do the same to the top. 4 times 3? Shad? 12 again. So the next step I like to follow is to do this. 12 plus 12 over 48. Anyone know why I like to do that? Chantal? Exactly. If I do 12 over 48 plus 12 over 48, some people might add the tops and then add the bottoms and end up with 24 over 96, which is not what I want. Again, it's the most common mistake, and it's the one that I'm going to be the most harsh on in terms of marking. It means that there's something critical about fractions you don't understand. Because really what I'm saying is I have 12 slices of a 48-slice pizza, and I have another 12 slices of a 48-slice pizza. So really what I have is 24 slices of a 48-slice pizza, not of a 96-slice pizza. The slices didn't get cut in half right away. So now, question?
Yeah.
Go.
Do we have to write the 12 plus 12 over 40?
Again, I'm never going to tell you have to do something one way or the other. As long as you can make it clear and your communication makes sense, you're fine. This, I find, just prevents a mistake. You know what I mean? You're just setting yourself up to not be put in that position. So, 12 plus 12? 24 over 48. Now, I want to talk briefly about the idea of reducing this to lowest terms. Yeah, it was a 48. 24 over 48.
It's half.
So, some people know right away that's half. That 48 is twice as big as 24, so it's 1 over 2. And if you're good at that, good for you. Any number that you can put or divide into the top and bottom, that's how you reduce these. Now, some of you will go directly to 1 over 2 because you'll divide both by 24 to make it smaller, and that's cool. Now, I want you to understand that these are the same fractions. This and this are equivalent. They're worth the same. The only difference is the size of the slice. So if I had this pizza here, it's cut into 48 pieces, which is ridiculous. I don't even know how many of these I'd have to do before it's going to be 48, but it's a lot. 48 pieces, whatever. I know it's not. I'm not a good pizza chef. This is split into 2. But if I eat this much pizza, I'm going to color a different color. If I eat this much, it would be 24 of the slices. if I actually did 48. If I ate this much, it would be one of the slices. But it's the same amount of pizza, and that's what I need you to get about fractions.
It's just.
Is that if they're equivalent fractions, it's the same amount, it's just the slices are different sizes. Okay? Good. Now, some of you won't be able to, in your head, and that's totally okay, go from 24 over 48 to a half automatically. So what you should be doing is just start simple. Any number you know goes into both. Those are both, 12 will go into both, but even smaller than that, still 2. I might start at 24 over 48 and know that, oh, they're both even, so I'm going to divide each by 2. That's going to get me to 12 over 24. Good morning. They're still both even, so I'm going to do that again. 6 over 4, or sorry, yeah, 6 over 12. They're still both even, so I'm going to do that again. 3 over 6. Now 2 won't go into both, but 3 will go into both. So I'll try 3 now. So that's going to be 1 over 2. Do you see how you can do that over and over and over and over again? And it'll still eventually get you to 1 over 2. This was just divided by 2. This was divided by 2. This was divided by 2. And this was divided by 3. Now understand, am I making the fraction smaller? No. I'm making the size of the slices actually bigger. I'm making the number of slices smaller, but I'm not making the size of the pizza itself any smaller. Does that make sense? Good. Next question, and then I'm going to start you guys on your problems. Express 5 and 3/7 as an improper fraction. So 5 and 3 over 7. Anyone want to explain how they did it? Give it a shot. Nora's not here. Mr. Sweeney?
Nora's not here.
She's the only, yeah, you have to write it. Do you want me to write it for you? And you just say it out loud?
Sure.
All right, fine, go. What do I do?
What I did was I multiplied 7 by 5, because how many times 5 went into 7, and then I added the 3/7.
Okay. So,
So it ended up being 7.
I'm going to slow you down for a second just to make sure. But you're right. He did 7 times 5 equals 35. Shh. What does that tell you?
That's how many, that's how big the numerator is to get 5 times into 7.
I understand what you're saying. I'm going to try and word it differently, and it's the way I'd like you to word it if you were going to try and communicate this to me. 7 times 5 tells you how many sevenths are in 5 holes. Would you agree? How many single sevenths? 1/7? How many of those 1/7 are in the 5 holes here, correct? You must understand that if you're going to use this multiplying method. Because you need to explain what you're thinking. You must be able to tell me that. 7 times 5, 35. That's what that is. This 5 holes equals 35 over 7. Correct? Okay, good. Now, there's still the element of the 3/7. So what do I have to do now?
3/7.
Right. So now I'm going to take 35 over 7 and add on 3 over 7. And that's going to equal 35 plus 3 over 7. I know they're sad-looking 7s. Equals 38 over 7. And that is totally one way to go about doing it. Now, guys, if you're going to sit back here, I can't hear you. Okay? Next. There's another way. It's the way Shahad did yesterday. The other way will be where the other way that you might want to consider it is 5 and 3 over 7 is really 1 plus 1 plus 1 plus 1 plus 1. That's my 5 plus another 3 over 7. Now, if I have to express a 1 as a fraction over 7, what would it be? Brooke?
7 over 7.
7 over 7. It's all of it. All of the sevenths.
Actually, I forgot.
So, that's what all of these would become.
You're so lazy.
And now I'm literally just counting by 7. 7, 14, 21, 28, 35, 38 over 7. And that makes sense. And there's a little less explanation required here because it's a little bit more kind of organically laid out. That being said, I would totally do it the other way. I would totally multiply and add, for sure. But if you can't remember that, or you can't remember what multiplies by what, start breaking it down to what it actually means, what it actually looks like. Yeah?
Like what I do, like if I really like all I do, because as I figured this out is I times 5 by 7, like, so any number that the denominator and then the big number, I just times them by each other and then I add the top number.
Yeah, that's exactly what we did in the last slide. But yeah, it's such a good idea. Just that idea of bottom times the whole number plus the top.
Don't work down. Question, just stay for homework.